Hello everyone. In this video, I want to show you three interesting and important items, especially one of them, dependent joint behavior in CoppeliaSim. So here I gonna open this scene that I got from one of the scenes that came with the installation folder. I just modified it and made it a little bit simpler so I can talk about it. So here we have two gears, and each one of them has a weight attached to it, which doesn't allow it to be in a balance situation, right? So here, as soon as we start the simulation, this gear, this weight that is not perfectly upright, starts falling down, and that makes this gear go up, and then this one has this weight attached to it, so it comes back, and this system keeps oscillating. So this is a system that is a dynamic system, and we're gonna see that the behavior of one of the joints does depend on the other one. In other words, the gear ratio that we know between the two gears, that the speed of one joint should be proportional to the speed of the other joint, and the ratio, which we call the speed ratio, is the ratio of the teeth or the ratio of the diameters. That, how can we incorporate that into the joint controls here, right? So if one of them is just going through the dynamics of the scene, the other one that should depend on it, how can I exactly incorporate that? We call it dependent joint behavior. The second thing you see here is, as soon as I open this scene, I got this custom message panel or UI, and it shows me some text which basically explains the behavior or the purpose of the scene. It says it shows how gears could be simulated with joint dependency constraint. Okay, yeah, and this is only supported with Vortex and Mujoko. Hopefully I pronounce it correctly. So how do I make such a thing? How do I make a message, a welcome message or something like this, explanation message? So we're going to talk about that. Another thing I want to talk about briefly is here, you see I added a dummy, which doesn't really play any role. And this script here is the script that explains it, right? It creates that explanation window, and I'm going to talk about it. But one thing interesting is, if you look at the color of this script, this is gray. But if I go ahead and add another script to this dummy, look, so I make a non-threaded Lua, look at that. This one is a white one. So is there a difference between this white script and this gray script? That is another thing that I want to discuss with you. Okay, so let's get to it. First thing is, how do I make this UI and show a message? So let's go into this script, which I'm gonna share with you on the video description, but let's see what it does. So here we bring in the sim, we start the initialization function, which is just gonna run one time in the beginning of simulation. Here, I'm going to use this command called auxiliary console open. And that is basically that window. It is going to open up a window, give it a title. That's the first thing you pass to it. The second one is the number of lines, maximum number of lines that this console will keep in its buffer. After 100, the first one will get overwritten. The next two are basically the flags for the behavior of this window. 2 means you allow the user to close the window, and 4 means initially the window is visible. So if you say 2 plus 4 means it has both of them. Then you give it the window position in the XY plane. This is basically the top left corner. And then you give it the width and the height. Here is 800 by 200, right? So let's say, for instance, if I want to make it a little bit narrower, I can make it like 100, okay? Or anything like that. And you can see that now, you see, I made it narrower, right? So it is completely up to us. And you see, this is the title of it, to make it big, small, or anything that we like. Now, once we have this window open, and you see by just clicking on this as restart the script, I could get the result, right? You see, as soon as I click on it, I get this result. Now, next, you provide the text that you want to write on it, and you see all of the text is written here between two brackets, and the text, the color of this text is blue. So this is going to be the text that you are going to be writing. Now you're going to show that text or print that text onto that console. So you use the command auxiliary console print, and you pass to the handle of it H the text, and it is going to write it. And finally, once you're done and the user closes it, you want to close the console, or at the end of simulation, so it's sim auxiliary console close. So very, very simple and easy to understand, right? So this is how you make a console and write whatever you want to it, right? And again, this is that console here. Okay, now that we learn about this, the next thing I want to talk about is, as I told you, you see there are two different types of scripts. They are both called the script. They look alike, except for one of them being gray, one of them being white. So what is the difference between these two? Let me explain that. The white one is the one that I have shown you a lot of times so far. This is a child script, and this is the kind of script that is related to an object in the scene. So it does basically run based on how that object is behaving. And the object could be a robot model, a shape, or anything. So basically it executes in the context of the object, and it could be threaded or non-threaded, okay? Typically, it handles local logic control, like you want to control the motion of a robot, the behavior of a sensor, the behavior of a graph, anything like this. When you want to control a local object or something, you use this kind of script. What is the gray one? The gray ones are either scene, basically, scripts, or they are called the customization scripts. What are they doing? So these are, for instance, look at this one here. This is not exactly gray, but if you look at it, this is the main script, right? And this one really doesn't do anything. It's just starting. But this one here, this customization, it basically controls something related to the scene. In this case, creating that console, right? Or you see, when you, let me show you, when you add a graph, let me bring a graph for you. If I add a graph here, right? Look, a graph has this script in it. This one, the job of this is to just create this console here, this basically window, right? And if you go and look at it, look at the command is, hey, just require model graph customization. You see, it's called the customization, right? And the job of this is, so here I restarted it, but if I basically run this, the goal of this is to give me that window. Now, if I want this graph to really plot something, as I showed you in previous videos, I have to add a specific script to it. And then in that script, I do the stream of the data. And in the stream of the data, I can put it on that specific graph. So these are two different things. One is a customization. One is really performing something related to an object. So I wanted to explain this. Now let's go to the most important thing I want to talk about. So here, let me run this for you first. So let's go ahead and run. Look. You see, the system keeps oscillating because this one here on the right is not perfectly vertical, so it starts falling down. The teeth are engaged. Now, how they are engaged? They are really engaged through code, and I show you through customizing the joints. And you see that this gear also gets triggered, and this weight that is added to it also keeps this one going back and forth. So how is these two joints, the motion of the two joints are related through a mode in the joint called dependent motion. So let me show you that. Here is the large gear and the mesh for it. Here is the small gear and the mesh for it. And these are the counterweights that are brought in. And then we have a connection for each one of them, which is basically, in this case, really a force sensor. And then each one of them is connected to an axis, which is a child of the base. Now look at these axes. So this is the axis of the big gear. If you go and look at it, the mode of running of this guy is dynamic. But there are three modes that a joint can behave. There is kinematics mode, dependent mode, or dynamic mode. Dynamic means the behavior of this joint depends on the dynamic of the scene, depending on the dynamics, depending on whether other objects are applying any force to this joint or something. Okay? So here we keep it as dynamic, and we are not going to actuate this, right? We are not going to apply any torque to it. So if you look here, I left it as free. So this is a free joint. The motion of it is determined by the rest of the objects and the forces from them. And another thing you have to pay attention to is if you look at this large gear and you look at the object, dynamic properties, you see this object is respondable and dynamic. Respondable, why is it respondable? Because we want it to respond to the forces from the other gear, okay? So you have to make this guy respondable. Otherwise, the normal forces from the teeth are not going to do anything. Right? So this one should be respondable. This one should be dynamic and free to move. Now, if you go to the small gear, look at the small gear. The small gear is also respondable because we want it to also be respondable to the force from the big gear, and it's also dynamic. Now, if you look at the joint of the small one, look, it's free, but there is a difference here. The mode, instead of being dynamic, it's a dependent mode. So the motion of this is not coming directly from everything else. It depends on another motion. Which motion? Here is where you define the formula. So once you pick dependent, now you say, I want to do dependency equation, and look at your dependency equation. The joint position for this joint is negative 1.6 times the motion of joint 1. You see, this is joint axis 1, which is this guy. So the rotation of this is 1.6 times that one with the negative, means the opposite direction. Now, you might say, where does negative 1.6 come from? That's the ratio of the teeth, right? This guy has 16 teeth. This one has 10 teeth. And you know the small one always rotates faster. So the ratio is 16 over 10, which is 1.6. And since external gears rotate in opposite directions, so if this one is positive, that should be negative, and other way around, vice versa. That's where that negative 1.6 come from. So you see, one of them is determined just from the forces and the dynamics of the scene. The other one is depending on this one. Okay, and this is how you can basically put two gears in action and provide the speed ratio. So hopefully you learn these important things in CoppeliaSim, and you are learning more and more. I have a few more videos for you to add to the playlist, and hopefully once you watch all of these videos, you're good to work on CoppeliaSim. Thank you, and I'll see you in the next video.